All right. So according to the typical flat Earth model, Danny, the Earth, in my first video, I called it a giant manhole cover, and some people didn't like that. But the general model is the Earth is this disk, right? The North Pole at the center, and the sun and the moon revolve around the North Pole, and they attribute seasons to the sun. Somehow, they don't have an explanation for how this happened, but the sun will somehow expand its orbit, and instead of circling around, say, the Tropic of Cancer, as the seasons change, it'll make a bigger revolution, and it'll kind of go around the Tropic of Capricorn. But if that's true, wouldn't the speed of the sun also necessarily have to change because it's going in a much bigger circle, and yet we don't see the speed of the sun going across the sky changing?
Yeah, they would argue that that the radius of the sun's daily motion changes throughout the year. It's a smaller radius in December, it's a larger radius in smaller radius in June and a larger radius in December. And it's turning around at one revolution per day. And so if you're on the end of the second hand on the clock, you're going to be moving twice as fast as a point only halfway out to the end of it. So you're absolutely correct. The speed would have to change. The linear speed would have to change. And of course, that would be noticeable as an angular change in the sky as well. And that's not what we observe at all. There are many problems with the sun motion in the flat Earth model. Yeah. Another problem is that throughout the day and throughout the year, the sun's distance from us would have to change. Right. In the middle of the day, the moon's highest and the sun's highest in the sky, it's going to be much closer to us than it was when it was low in the sky, appearing to rise. And you can work out the math on that. I've done that. It's basic trig. Any high school students taking a good math curriculum can work this out. Mm-hmm. And so the angular size of the sun should change throughout the day. And I photographed the sun at various times throughout the day, and it doesn't change. It does change by about 3% throughout the year, but it doesn't change throughout the day.
But the fool on the hill sees the sun going down, and the eyes in his head see the world spinning around.
Right. And the photo, I've seen these videos, but by flat earthers or photos, they seem to show the sun, sure enough, is bigger when it's directly overhead as opposed to when it's far away. But that's simply the exposure and the brightness, right? It makes the sun appear to be larger when it's really not.
When they show the sun up high above the horizon, it is grossly overexposed, and so you bleed out and all these other things. And I've demonstrated this myself a few times. I have a solar filter I put on my camera, and I'll take photographs at different times. I made a time-lapse video just last week where I caught the sun just as it rose, and I didn't have the solar filter on it. And then when I put the solar filter on it, it kind of shrank down like it should, because now the exposure time's right. And as the next couple hours went through, the sun got higher in the sky, but its apparent size did not change. So with proper filtering, you can see that. But when they see this grossly overexposed sun, they think they're seeing the actual angular size, the apparent size of the sun, and they're not. They're seeing something far larger than that because of the big blob of light.
Yes. Right. Okay. And to reiterate again, if the sun makes larger loops depending upon the season and other seasons, you say that for the larger, the sun would have to be traveling twice the rate of speed
Well,
as it does.
not necessarily twice. I'd have to work out the numbers. I'm simply using an example of a second
Okay.
hand. The middle of the second hand is going to move half the speed of something at the end of the second hand,
Right.
but it would have to be quite a bit larger, faster speed, since it's out by the Tropic of Capricorn than it is the Tropic of Cancer.
Noticeable.
I don't have time to work in my head
Yeah.
what the speed would be, but it would be a noticeable change.
Whether it would be noticeable, it'd be unmistakable, and yet
Yep.
we do not. That in and of itself puts an end to the flat Earth model.
Hey everybody, Flat Earth Dave here with a simple little video about seasons. So we're taught that the sun rays from a 93 million mile away sun come in straight, and it's the tilt of the Earth that causes the season. So here we have the northern hemisphere. When we're tilted towards the sun, we have direct rays and it's hot. And when we're tilted away, the rays come in at a more shallow angle and it's colder, right? A lot of people don't realize that during our northern summer, the Earth is 3.5 million miles closer to the sun, but the globers say that doesn't matter. That's only a couple of percent. It's the angle that comes in. Well, you have to remember, if you can tilt the ball this way or this way, you can also tilt it this way. So every day we tilt all the way away from the sun and then all the way back as we come around. So at sunrise, the angle to the sun couldn't be any more severe. It's skimming across all of the atmosphere. In the summer, distant sun, farther sun, sunrise, it should be arctically cold here in the Northeast, but it's not. You can feel the heat of the sun. And then during, that's when it's at the steepest angle. And then at the highest point of the day in December, when we're actually closer to the sun, we have much more direct rays than sunrise. In the summer, I can't even feel the heat on my face. So the whole tilted thing is ridiculous. And if you look at this heat map here, how come the heat isn't tilted? I mean, it should be parallel. The heat ring should be parallel with the sun rays coming in. But on a flat Earth, with the sun migrating in between the two tropics, that makes sense that this area would be heated up more than the outer and the inner area. Very, very simple. So now let's look at this. So on a globe model, we have our 93 million mile away sun. In the mornings, it's cooler. And then at noon, we have a 93 million mile away sun and it's warmer. And in the evening, we have a 93 million mile away sun and it's cooler again. On a flat Earth model, in the morning, we have a farther away sun. We don't know the distance. But at noon, the sun is much closer and it's hot. And then in the evening, we have a farther away sun and it gets colder again. Which one makes sense? You look at it on the regular Mercator map. This is the Tropic of Cancer in June, right? It's near all of these northern places. That's why it's warm. And it's winter down here. Then in December, the sun's down here. If we look at it on a flat Earth map, here's June. The sun circles around. It's closer. So it's warmer. It's very, very simple. Now, the sun sets when it moves a distance away from you, whatever that distance is, depending on your topography, where the sun will just disappear behind or beyond the horizon. So here I'm in Connecticut. Over here, the sun's so far away, I can't see it. It's nighttime. Comes around, gets closer to me again, it rises. But if you're way in the middle north, the sun never gets far enough away from you to set. It just circles around. It just circles around. The same should be true in the south. If the Earth was a globe, same latitude north in December, should have a 24-hour sun. but we only get faked videos of 24-hour suns. There's hundreds, countless videos. You can go witness this yourself in the north. You can't ever see it in the south. This is called the analemma. It used to be on globes, but strangely, they've pretty much removed it. And so this person took from the same shot, took a picture at noon every day or every week, whatever, how many dots there are there, over the course of a year. And this is June 21st, and this is December 21st right here. The reason the circle is bigger in the south is because the sun actually has to go faster. So a lot of people don't understand how, if the sun goes faster, wouldn't it race across the sky? And the answer is it would not race across the sky, but sunsets and sunrises would happen faster. The transition from sunset to darkness changes. Now, if the Earth was a globe, there would be symmetry in June at a northern latitude and in December at a southern latitude. But that's not what we experience. The changes of light are very, very different. And what we're noticing is everywhere on the Earth, everyone has their own topography, their own latitude, the different amounts of light. That's all explainable. But what's not explainable on a globe is why after sunset from September, October, November, and December, does the amount of time from sunset to darkness get shorter. It gets shorter for us in the north because the sun's going farther away. It's going south, but it should be getting longer if we lived on a globe. But everywhere, every location, doing measurements, we'll see that the sun from darkness, from sunset to darkness is speeding up. And then after December, it starts slowing down. And that's because the sun is going in, it's coming into the tropic of, let me turn this on. It's coming in closer to its inner circle. So right now we're just about at, we just passed the equinox, it's March. And the sun will come in here and it's traveling a shorter distance. So it's actually moving slower. And therefore the transition from day to night or from sunset to darkness is slower, but it's slower for everybody everywhere on Earth. That is impossible on a globe. Okay, here I've placed a glass dome on a rug, and I'm holding a light up in the air, and I'm just going to go travel right across the top. And we're going to watch the light appears in here, and it does its circle. Now, if I was circling that light around, whether I'm making a bigger circle or a smaller circle, but at the same revolutions per minute, the sun would transition over that dome in the same amount of time. It's only when it goes down to there that the light will run away faster when it's out over the Tropic of Capricorn. So when the sun is way out here, let's move it out. July, August, September, October, November, December. So in December, when the sun's out here, in the same 24 hours, it's making a faster circle. The observations of the time from sunset to darkness increasing through December and decreasing through June worldwide completely nullifies the globe model. The globe defenders have no explanation for why that happens. They would just want to ignore it because it destroys their ball. On the app, if you go to the frequently asked questions and then you click seasons, you'll get all of these videos here explaining how the sun works, how the seasons work. that YouTube is hiding from you. For some reason, they don't want you to see these videos. Watch these videos, and it clearly explains the simplicity of how the sun works. And a simple experiment that I talk about is two people sitting outside. It's really cold out, and somebody holds, they're 20 feet apart, 50 feet apart, whatever it is. Somebody holds a big heat lamp 10, 15 feet over one person, directly over them. That's their summer sun. It's warm, it's close, they can feel the heat. The person sitting 25 feet away, they're cold. They don't see the sun above them like that person. They see it over there, maybe at a 45-degree angle. And if that person walks over, keeping that light at the exact same height over the ground, that other person is going to start seeing that sun get higher and higher in his visual perspective, and it's going to get closer. Closer, warmer, farther, colder. Closer, higher, farther, lower, due to perspective. These are things that Globers don't want to understand. That's it.